Welcome back, everyone, to the deep dive. Ready to explore something pretty cool.
Absolutely. Always up for a deep dive.
Today, we're talking all about 3D printing, but with liquid metal.
Sounds fascinating already.
It really is. And we'll be looking at some cutting-edge research from MIT.
Always at the forefront of innovation, those MIT folks.
So they've come up with this new technique, and it's called liquid metal printing, or LMP for short.
LMP, catchy.
And, this isn't just for like the hardcore tech enthusiast or anything.
Right, it has some serious real-world potential.
Big time. It could completely change how we think about sustainability, design, even what your furniture might be made of someday.
I'm intrigued. Let's dive in.
Okay, so picture this. You got a furnace, like a super-powered blacksmith's forge,
Oh yeah, I'm visualizing it.
But instead of hammering the metal, it's totally melted down and flows through a nozzle like liquid.
So it's kind of like freeform casting, but with way more precision because you have the control of a 3D printer.
You got it.
Like a robotic arm guiding that molten metal, building up an object layer by layer.
Exactly. And get this, they're using scrap aluminum.
Really? So they're taking waste metal and turning it into something new.
Yep.
That's brilliant. Talk about a win for the environment.
Right.
It fits right in with that whole circular manufacturing concept,
Right.
reducing waste and lowering the environmental impact.
Totally. And aluminum is super energy intensive to make from scratch.
Oh yeah, huge energy hog.
But when you recycle it, it only takes like a tiny fraction of the energy.
Wow, that's amazing.
So it's not just cool tech, it's also eco-friendly. But wait, there's more.
Oh, there's got to be more. I can feel it.
LMP is also super fast.
Really? How fast are we talking?
Like build a chair in seconds fast.
No way. So that's a big difference from other types of metal 3D printing then.
Huge difference. Because those can be so slow and expensive.
Right. Makes sense.
So with LMT, you're trading some of that super fine detail for speed and the ability to scale up, make bigger things.
I see. So you're thinking furniture, architectural elements, maybe even parts for cars down the line?
Exactly.
That's incredible.
And speaking of furniture, they actually built a chair using LMP.
No way. A whole chair.
A whole chair.
I'm dying to know how that works.
So they use this technique they call oblique overlapping.
Oblique overlapping. Okay.
And it's basically they lay down the molten aluminum in a specific way to make like thicker and thinner parts.
So like thicker where the chair needs more support and thinner where it needs to flex a bit.
Yeah, you got it.
That's really clever.
And they didn't just print the whole thing out of metal either.
Really? What else did they do?
They combined the printed aluminum frame with a maple seat and back.
Wow, so it's like a blend of old school woodworking and this futuristic printing technology.
Yeah, exactly. The best of both worlds.
It's fascinating how they brought those two together.
And this whole process is controlled by a numerical model they developed.
Okay, a model. What does that do?
It basically predicts how the molten metal is going to behave based on things like the nozzle size, the printing speed, how deep they're printing.
So it's like a super smart computer program guiding the whole thing.
Exactly.
That's amazing.
And that's how they get such consistent and accurate results.
I can see why that's important.
So what does this all mean?
Well, it seems like LMP could really shake things up.
Yeah.
I mean, think about it. It opens up so many new possibilities for making things in a sustainable way.
For sure.
And rapid prototyping, too.
Right.
Imagine being able to print a prototype in a few seconds instead of waiting hours or even days.
Right.
And then there's personalized design, too. You could print furniture that's custom fit to your body.
I love that. Or one-of-a-kind architectural details for your house.
Exactly. The possibilities are truly mind-blowing.
It really feels like a glimpse into the future of manufacturing.
It does. It really does. It's a game changer for sure. But, it's got to be tough working with molten metal, right?
Oh yeah, I can't imagine it's easy. I mean, one wrong move and things could get really messy.
Exactly. Melting and shaping metal like that comes with its own set of challenges.
So what were some of the hurdles they had to overcome with LMP?
Well, one of the biggest ones was dealing with corrosion. Aluminum is super versatile.
Right, very common metal.
But it can also be pretty corrosive, especially at high temperatures.
Ah, I see. That makes sense. So how did they get around that? Did they have to create special equipment or something?
They did. They actually had to design a custom furnace.
Wow, a whole furnace.
Yeah, one that could handle those crazy high temperatures.
So what, did they use some kind of special metal or?
They used refractory bricks and these special heating coils that can pump out a whopping 5 kilowatts of power.
5 kilowatts, that's intense.
It is.
What about the nozzle though? Wouldn't the molten aluminum just eat right through it?
You'd think so, right? But to keep that molten aluminum flowing smoothly, they had to get creative. They use a combination of stainless steel and ceramic for the nozzle.
Ah, so those can handle the heat and won't corrode as easily.
Exactly.
Sounds like they had to do a lot of problem solving to make this work.
Oh yeah, for sure. But it wasn't just the equipment they had to figure out.
Right, there's the whole process of actually printing with the liquid metal.
Exactly. Controlling a flow of molten metal.
Mhm.
It's not as simple as it sounds.
I bet. So what kind of challenges did they run into there?
Well, they had to account for all sorts of factors that could affect the final product. Everything from the diameter of the nozzle to the speed of the robotic arm, it all plays a role.
It all matters, huh?
Oh yeah, big time. You give it too much pressure, you end up with a molten mess all over the place.
Yikers. So it's a balancing act.
It is. And then there's this thing called Rayleigh instability.
Rayleigh instability sounds ominous.
Basically, it means that molten aluminum doesn't flow in a perfectly smooth stream like water.
Oh, how so?
It tends to form these little droplets
Really? Why is that?
because of surface tension.
Ah, so that's where that super smart computer model comes in.
Exactly. That model let them predict how the molten aluminum would behave and adjust everything accordingly.
So they really had to understand the physics of it all.
They did. And to test their understanding, they did a bunch of experiments, printing all kinds of shapes and structures.
Oh, cool. Like what?
Well, they started with simple things like straight lines and overlapping beads, just to get a feel for how the molten aluminum would bond together.
Okay, makes sense. Start simple.
Then they moved on to more complex stuff, like frames and even spirals.
A spiral. That sounds tricky.
It was. As the molten aluminum cooled, it would form this solid layer of oxide on the surface.
Oh, like a skin.
Exactly.
Right.
And that made it tough to create a smooth, continuous spiral.
I can see that being a problem.
Mm.
But they figured it out.
Yep, through trial and error, they found ways to overcome those obstacles.
That's amazing. They really pushed the limits of what's possible with this tech.
They did, and that chair they built, it's a perfect example of what LMP can do.
Yeah, let's talk more about that chair. It's hard to picture something as elegant and functional as a chair being made out of liquid metal.
Right. It seems counterintuitive.
So how did they actually go about building it?
Well, they used that oblique overlapping technique we talked about earlier to make the aluminum frame. They layered the molten metal in a specific way to give it strength and stability where it needed it most.
Okay, and then they added the wooden seat and back.
Exactly. They used traditional woodworking methods to seamlessly integrate the wood with the printed aluminum.
So it really is a fusion of old and new craftsmanship and cutting-edge technology.
Precisely. And the result is a chair that's both beautiful and functional. It really shows off what LMP can achieve. You know, you can create objects that are aesthetically pleasing, A&D structurally sound.
It's pretty inspiring. But I'm curious about the limitations of LMP. You mentioned earlier that it trades off fine detail for speed and scalability. Does that mean it can only be used for creating relatively large objects?
That's a great question. For now, yeah, it seems like LMP is better suited for larger objects where those tiny details aren't as critical.
Okay, so maybe not printing microchips with liquid metal just yet.
Right, not quite there yet. But, you know, the researchers are constantly refining the technology.
So you're saying it has potential to evolve?
Absolutely. The possibilities are pretty vast.
Yeah.
I mean, just think about the potential for architecture, building massive structures.
Well, yeah, like whole buildings printed out of liquid metal.
Exactly. Or even gigantic works of art.
It's pretty mind-blowing to think about. But let's come back down to earth for a minute. Why aluminum specifically? What makes it such a good fit for this technology?
Well, aluminum is like the recycling superstar.
How so?
It can be recycled again and again without losing any of its strength.
Oh, interesting. So it doesn't degrade over time.
Nope. It keeps its properties, which makes it perfect for this whole circular manufacturing idea that LMP is all about.
Right. So it's a perfect match for a technology that's all about minimizing waste and conserving resources.
Exactly. And aluminum has some other great qualities too.
Like what?
It has a relatively low melting point.
So that makes it easier to work with.
Exactly. Less energy intensive. And it's also lightweight, but still strong.
Ah, so it's versatile.
Very versatile. Suitable for a ton of different applications. And let's not forget, it's incredibly abundant.
Meaning we're not going to run out of it anytime soon.
Nope. Aluminum is actually the most common metal in the Earth's crust.
That's good to know. So it's sustainable from multiple angles.
Exactly. But did they look into using any other metals for this process?
That's a good question. I'm curious too.
Their main focus was aluminum for this research. but they have mentioned the possibility of using other metals down the line.
Oh, really? Like what?
They haven't specified any particular metals yet, but they've even talked about printing with multiple metals in a single design.
Whoa, multiple metals. That's wild.
Right. Imagine being able to create an object with different properties built right in, like strong in one area, flexible in another.
That would be incredible.
Yeah.
The possibilities are truly endless.
They really are. But it's important to remember that LMP is still relatively new. There are definitely some hurdles to overcome before it becomes mainstream.
Like what? What kind of hurdles are we talking about?
Well, one challenge is achieving the same level of detail and precision you can get with some other metal 3D printing methods.
So you're saying it's great for large-scale stuff, but maybe not quite ready to print tiny, intricate objects.
Exactly. But they're working on it. Another challenge is figuring out the safety protocols and industry standards for working with molten metal, you know?
Right, safety first. We don't want people melting stuff down in their garages without taking the proper precautions.
Exactly. And then there's the cost factor, too.
Ah, right, the economics of it all.
The equipment needed for LMP is still pretty expensive.
So that could be a barrier to entry for smaller businesses or individuals who want to experiment with the technology.
Yeah, for sure. It's accessible for research and development, but it's not quite ready for mass production and widespread use just yet.
Okay, so it's early days, but the potential is huge. I'm also curious about the artistic possibilities of LMP. Could artists use this to create sculptures or other works of art?
Oh, absolutely. LMP would be amazing for artists.
How so?
Imagine sculptures created from molten aluminum, you know?
Wow, yeah, that would be something else.
Each one would be totally unique, full of dynamic shapes and textures. It'd be like capturing liquid metal in a solid form.
That sounds incredible. It'd be a whole new art form.
It would. And it's not just about aesthetics either. Artists could experiment with the structural properties of the metal, creating pieces that are both visually stunning and super strong.
So it's like a fusion of art and engineering.
Exactly. I think LMP could really inspire a whole new generation of artists and makers.
I love that idea. What about the educational aspect? Could this be used in schools and universities?
Oh, for sure. LMP would be a fantastic learning tool.
For what kinds of students?
Students studying engineering, design, even art.
Wow, so it has applications across disciplines?
Yeah, it does. Imagine students getting hands-on experience with material science, designing and printing their own creations.
That'd be amazing.
Right. They could push the boundaries of this cutting-edge tech.
It's a great way to get young people excited about STEM fields.
It is. And it's not just about technical skills either. LMP encourages creativity, problem-solving, teamwork. Students working together on these projects would learn valuable skills that they could apply to anything.
I love that. It's so cool to see a technology that's not only innovative, but also has so much potential to inspire and educate.
I agree. It's really exciting. This has been an amazing conversation.
It really has. We've learned so much about LMP, from the nitty-gritty technical details to its potential impact on everything from manufacturing to art and education.
It's truly a technology with the potential to change the world.
Before we wrap up, I want to circle back to one of the key themes we've touched on throughout this whole conversation, and that's the importance of embracing a circular economy.
Couldn't agree more. It's crucial for a sustainable future.
And LMP's ability to use recycled aluminum is a perfect example of how we can move away from that linear model of take, make, dispose, and towards a more regenerative system.
Absolutely. It shows we can create a closed loop, minimizing waste and conserving resources.
And it's not just about the technology itself, it's about the choices we make, the values we embrace, the future we envision.
It's about recognizing that we all have a role to play in creating a more sustainable world.
This deep dive has been truly eye-opening. We've explored the incredible possibilities of LMP and its potential to revolutionize not just manufacturing, but how we think about materials and design in general.
It's been a fascinating journey into the future of making things.
And as we've seen, it's not just about the technology itself. It's about the choices we make, the values we embrace, the world we want to create.
It's a call to action to embrace a more circular, sustainable, and equitable approach to manufacturing and consumption.
We hope this deep dive has sparked your imagination and inspired you to think differently about the future of manufacturing and the role we all play in shaping a more sustainable world.
Remember, the future is not something that just happens to us. It's something we create together through our actions and our choices.
Thank you for joining us on this incredible journey into the world of liquid metal printing. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible. What applications of LMP spark your imagination? We'd love to hear your thoughts.